The next thing in the ACI is something called as a tenant. And I'm sure you are pretty familiar what is a tenant. So tenant is all about a container in ACI. Where once you configure your policies, it acts as a container, so you can apply certain policy to only one tenant, certain policies to the other tenant. So for this example, we are taking two tenant. We creating a tenant by name Pepsi. There is another tenant by name Coke. The tenant resources pretty much are isolated. So whatever's in Pepsi, Coke can see, and vice versa. And these resources are completely isolated, allowing management by different administrators. So you can literally assign a different user where they get to see their own tenant only, and they can work with their own tenant only. So they cannot see what else is inside ACI. So that's another great thing about ACI. It's fully multi-tenant, has full RBAC functionality and some of those things. So once you have a tenant, within a tenant, we'll go ahead and create something called as a private network. Some of the documentation may refer to private network as a context, or you may see some of the documentation referring private network as a VRF also. I'm sure you are familiar with VRF. So the private networks are defined within a tenant. So we create these private network within a tenant to allow isolated and potentially overlapping IP address spaces. So you can have even overlapping IP addresses within a tenant. So let's say in this example, in the Pepsi, we created a private network 1 and private network 2. I could literally have the same private network with the same subnet into the Coke tenant also. Because if you recall, the tenant acts as a container. It's completely isolated. So that way we can have an overlapping IP addresses too. Now, once you have private network created, in the private network, we'll go ahead and create something called a bridge domain. This is very important for you to understand what is a bridge domain. So within a private network or a context or a VRF, we can have one bridge domain or we can have multiple bridge domains. So think of a bridge domain as a layer to forwarding. So think of it like a big switch, but it's intelligent switching got multiple, many more things. But if I have to just tell you in one single line, think of a bridge domain as a switch. It's a layer 2. It's layer 2 forwarding. That's all, guys. Construct within the fabric. Again, the fabric we're referring to a combination of all of these ACI 9000 spine and leaf combination. And this bridge domain, as the last line says, used to constrain broadcast and multicast traffic. So the bridge domain, as we said again, acts as a switch. You are using the bridge domain really to contain your broadcast and multicast traffic. So once we do the practical, you will have different options and you will get to see how we are using a bridge domain. But just keep in mind, the bridge domain is a layer 2 forwarding construct. You can have one or more multiple bridge domain, and these bridge domain belongs to a network or a VRF or a context. So now the question really comes, how do we design our physical fabric? So before I show you the next slide, I really need you to tell me what are the things that makes up the whole ACI solution. I'll give you a couple of seconds to think about. Okay, if you guessed it right, to make up the whole physical fabric, you would need a spine and a leaf. And to provide that whole intelligence, obviously you would need an APIC. Without an APIC, it's not an ACI solution. That would be the NXOS mode or the standalone mode. So to design our physical fabric or the ACI solution, you will need 2 or more spines. So you can have 2 spines, 3, 4. And again, as I said, I would highly recommend you to, if you are deploying in production, go ahead and read the best practice or design papers or some of more things. But at a minimum, you would need a spine switches and you would need a leaf switches. And if you see one thing in particular in this diagram, that each leaf is connected to each spine or vice versa. So this leaf has 2 connections. One goes to this spine and this goes to the another spine as the same thing. and needs to be fully meshed. And another thing, important thing to pay attention here, that we never connect one leaf to the another leaf. There is no connection between leaf. If this leaf, let's say on the leaf on the left hand side, needs to talk to the leaf on the right hand side, they will send this traffic back to the spine, and then spine will switch or forward that traffic back to the another leaf. There is no direct connection, a physical connectivity of any nature between leaves. The leaf always connects to the spine and spine always connects back to the leaf. There is no connectivity between leaf, and we don't connect any kind of devices other than leaf to the spine. Any kind of end host devices, router, switches, anything that you can think of, we usually go ahead and connect them to the leaf. So to make a fabric, we need spine switches and we need something called your leaf switches. Now we understood that we can have multiple leaf switches. We can dedicate these leaf switches to do certain function or to carry out certain activity. So in this, here you are saying that we are with these leaf switches, we are connecting our server. So it could be physical server or virtual server. So that's the reason we are calling them server leaf. Sometime you may hear them as a compute leaves also, which is the same thing because you're connecting your compute resources. So you will say compute leaf or server leaf. Just because we are connecting server, that's the reason we are calling them a server leaf. Similarly, on the right hand side, we are connecting some routers, some cubes back to the leaf, and that's the reason we are calling them as a border leaf. There are leaf where we are connecting our firewall functionality, load balancer, and that's the reason we are calling them service leaf. If you don't have that many number of leaf, you can always have everything connected to one leaf or two leaves. So literally I can have on the server leaf a firewall connected as well as a router connected. But in that case, that same leaf is acting as a server leaf, a service leaf, as well as a border leaf. So now the question comes in, what's the technical difference between these different leaves? Any guesses? Okay, if you guessed it right, technically there is no difference between any of this leaf, except we have just dedicated few devices back to these leaves. So we are calling them a server or compute service or border leaf. Technically they are same leaf. You can go ahead and connect anything to any of these leaf switches.